Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science contest. This is a grade 11 Math Hypatia contest question. It's question number 2, and it has 4 parts to it, culminating in part D, which says if we have this trapezoid and a line that passes through B and D, what are all possible points P that could be on that line that would give the area of the triangle PAB to be exactly 42. Give them all a try, and I'll be right back with their solutions. Okay, so part A asks for the area of this trapezoid. Well, the area of a trapezoid is equal to the average of these lengths, DC and AB. So we're going to write that as DC plus AB over 2, multiplied by the height, which would be this here. Let's call that H. Okay, so let's figure out what all these lengths are. So first, DC. Well, that's a difference in our x-coordinates, and our x-coordinates are 2 and 11. So 11 minus 2, their difference would be 9. So here we have 9. Plus AB, again, difference in x-coordinates, which would be 0 and 12. So that's just 12. Divide that by 2. And multiply it by their height. Now their height is going to be the difference in their y-coordinates. So these y-coordinates are 0. These are 5. So the difference would be 5. So this leaves us with 9 plus 12, which is 21, times 5, which is 105, all over 2. There's the area. Alright, so part B says the line passing through B and D, which would be right here, intersects the y-axis at E, so right here. What are the coordinates of E? Well, to first figure that out, we're going to need to figure out the slope of this line. So the slope, which is m, and we can use the coordinates d and b to figure out the distance between the slope. So slope is rise over run, or put more mathematically, it's the difference between our y-coordinates, so let's call it y2 minus y1, divided by the difference in our x-coordinates, x2 minus x1. Alright, so let's start with our y-coordinates. So here we have 5 and 0, so that's going to be 5 minus 0. And our x-coordinates will be 2 and 12, so 2 minus 12. It doesn't matter which you choose to be 1 or which you choose to be 2, as long as you stay consistent with it. So this is going to leave us with 5 over negative 10. Or a slope of negative 1/2. Alright, so there are a couple ways you can find this point. Let's look at the equation of a line. The equation of a line is y equals mx plus b. Now we already figured out what m is, so that's y equals negative 1/2 x plus b. To figure out what b would be then, all we need is a point on the line. And we have 2 of them. Let's use point b. So we're going to substitute these x and y coordinates in, and then solve for what b is in this equation. So our y coordinate is 0, and our x coordinate is 12. So solving for b will bring this whole term to the other side of the equation, making it positive. 12 divided by 2 is 6, so this leaves us with 6 equals to b. So that means the equation of our line is y equals m, which is minus 1/2, x plus b, which is 6. So now to figure out what that y-intercept is for that line, we simply set our x-coordinate equal to 0 and solve for y. And so when we do that, we get 6. So point E will be at 0 and 6. Alright, so part C. In this part we have the sides AD, like so, and BC, like so. And the question says they are going to intersect at F, so let's call this F. Determine these coordinates for f. So to do this, let's call this one line 1 and this one line 2. Now let's find the equations of these two lines. So line 1, we're going to start by finding the slope, just as before. So in this case, the slope will be change in our y-coordinates over the change in our x-coordinates. So the difference in y would be 5. And the difference in x then would be -1. So that's a slope of -5. Looking at equation 2, we can do the same thing and find its slope, which is the difference in its y-coordinates. And here we have 5 and 0, so we're going to have again 5, divided by the difference in its x-coordinates, which in this case is 2. So its slope is 5 over 2. And it actually shows us our y-intercept, which is 0. So immediately we know the equation is y equals 5 over 2x. And we don't need to solve for b because we know that that y-intercept is going to be 0. Therefore, b will also be 0. Now for equation 1, we can write that as y equals minus 5x plus b. Use any coordinate we like to solve for b, just like we did in part b. And when you do that, you'll get y equals minus 5x, and you'll get b to be 60. So now that we have these equations for each line, we can find out their intercept by solving those system of equations. So let's equate our y equations, which would give us minus 5x plus 60 is equal to 5 over 2x. Now if we collect like terms, we have 60 equals 5 over 2x plus 5x, which gives us 60 equaling to 15 over 2x, or x is equal to 60 times 2 divided by 15, which is 8. Now that we know the x-coordinate, we can simply substitute that x-coordinate into either one of your equations. This one's pretty simple, to figure out what the y-coordinate is, which would be 5 over 2 times 8, which is equal to 20. So the coordinates for f then is 8 and 20. Moving on to part D, if we were to connect the lines B and D, we need to find all possible points P which would lie on that line. So let me give you one example. Maybe there's a P in here where this triangle APB will have an area of 42. So let's start by saying that P has some coordinates RS. Now the area of a triangle is just 1/2 base times height. Now we know that this base is 12, but we don't know what the height is going to be. But we do know that that area is supposed to be 42. So that leaves us with 6h equaling 42, or h equals 7. So that tells us that P is some vertical distance 7 units above the line AB. However, if we also extend this line, we can see that there could be a P here that would also give you an area of a triangle to be 42 if the height is 7 units below our line AB. So far we have two options for P. So let's start by looking at the case where P has coordinates R and positive 7. So this is the one where we are above the line AB. Now from question B, we learned that that line BD has a slope of -1/2 and an equation of y equals minus 1/2 x plus 6. So since P lies on this line, and we know what the y-coordinate is, we can simply substitute that y-coordinate in for y, so that gives us 7 equals minus 1/2, the x-coordinate we'll call r, plus 6. Now rearranging, here we have minus 1/2 r equals 1, and therefore r is going to equal negative 2. Therefore, this p has the possible coordinate of negative 2 and 7. So now let's do the same thing for the p, which has x coordinate r and y coordinate negative 7. It's this one down here, which is below the line with coordinates r and negative 7. So we're going to use the same equation, y equals minus 1/2 x plus 6, where we have y as negative 7 equals minus 1/2 r plus 6. So now if we rearrange this equation, we get minus 1/2 r equaling to minus 13, or r equals 26. So this one has the possible coordinate of 26 and negative 7. Those are our two values for p that will give the area of this triangle to be 42.